This is sixth part six of visual acuity, and today I am going to discuss about retinal luminance due to visual acuity chart and visual acuity chart luminance, and very short topic. Okay, just move forward. So first of all, I want to just re-emphasize what is luminance. Luminance, we know it, isn't it? We know it. It's lux divided by steradian into meter square, which means the luminous flux emanating from the surface, which is lux, uh, sorry, lumen, I'm sorry, not lux, definitely lumen per solid angle, which is steradian angle, and a unit of projection area, which is meter square. And sometimes lumen divided by steradian is called candela per meter square, and candela per meter square sometimes we call it nit. One candela per meter square is called one nit. So this is the basic unit, which is luminance is lumen per steradian per meter square, which is basically luminous flux emanating from surface per solid angle, which is definitely lux at particular area. Okay, so visual acuity is affected by the amount of light reaching the retina, isn't it? What if it's not, it's photopic, and what if it's scotopic? Because in case of scotopic, cone doesn't work. In case of photopic, rod doesn't work. But whatever, we are talking about visual acuity in the photopic visual acuity, isn't it? We're not talking about visual acuity as a scotopic visual acuity. Whenever we are talking about visual acuity as a macular visual acuity, that is central visual acuity, we are not talking about the peripheral visual acuity. That's very important to understand, because sometimes we can talk about visual acuity of peripheral visual acuity, not central visual. We're currently talking about visual acuity that is macular, that is central, that is uh, photopic, not scotopic. Okay, so that affect the light reaching, affect the retina. If light reaching the affected reaching the retina is less than 100 Troland, or luminance is less than 100 Troland, then in that case we consider it as a scotopic condition. So which involves the eye chart luminance and background of the luminance and pupil diameter. We know we will discuss a lot of things. Okay, background of the luminance and pupil diameter, how it correlates with it. And as I have already told you, one candela per meter square is also one nit. Okay, so to make things equal everywhere, US National Academic Science National Research Council recommended the standard eye chart background 85 nit, but that's not followed at all throughout the world. That's not followed, but it's a guideline given by national. However, it is not universally followed. The luminance for original ETDRS study, okay, at that 200 nit, but at Germany it is standard is 300 nits. It's higher. In United Kingdom it is 120 nits. So I'm again emphasizing nit means one candela per meter square is equal to one nit. Okay, so because nit comes from the word nitere, which means the sign. Okay, so that's why you use nit. So it's not universal that 85, it's not universal that 120. Every country adapts according to them, and some country follows another country. Okay, it's completely okay. So human visual system reached the photopic operation at around 100 Troland. What do you mean a Troland? First, let me explain Troland. Troland is a unit of conventional retinal illuminance, and it's based on the, I think, one of the scientists' name. So Troland is unit of retinal illumination, and I have already told about the Troland in previous video. So eye charts relate to retinal treatments via the pupil size. So there is simple formula. There is no relation of the distance, just multiplying eye chart luminance with in nit and multiplied by pupil area. Just remember pupil area. That's it. Finished. Just for example, if the chart has 160 nit and pupil area is 3.14, because 2 mm pupil, which means r is equal to 1 and pi r square is 3.14. So simply retinal luminance is 160 into 3.14, which is approximately 500. Okay, that's the concept. It's simple as that. Okay, let's do one calculation. So I'm just doing this calculation to make sure it's 100 nit. Finished. I want pupil area, which is 2 mm is the diameter, 1 mm is r, is 1 mm, isn't it? Radius square is a pi, r square, pi is 3.14 into r square, 1 is 1 square, which means 3.14 mm square is a pupil. So 100 into 3.14 means 314 Troland TD is the, what is that? Retinal illumination is the answer. So it's simple. Just try to calculate Troland. Very simple. Just remember, greater than 100 is photopic vision. So we come to conclusion that if 100 is the visual acuity chart luminance, and patient's eye has diameter is 2, at that condition it's completely photopic condition. Okay, just remember this point, which is very important. Sometimes it came into MCQs too. Just remember. Okay, so that's the conclusion. Retinal illumination is a new thing that you will understand, and you know how to calculate it. It's simple chart illumination into area of people in mm square. Just simple. And another thing, you know the term Troland, you know the term nit. It's basically candela per meter square, isn't it? The unit of very unit of luminance. So these are the 3 4 things you understand, which is very crucial when we move forward, and when we talk about the charts, and when we talk about the illumination system, when we talk about the low vision in upcoming videos. So just remember these few things. And finally, this is my favorite book of all time in optics, visual optics, especially by Professor Dr. George Ismaili. Just go through it. Okay, bis dann, tschüss.